Hey guys, what's up? It's Timothy Wu here again, and today we'll be investigating how to turn your LTE Shield into a GPS tracker. So imagine things like an auto theft prevention device or tracking device, or just IoT data logging in general. So you can send pretty much anything, like temperature data, GPS, latitude, longitude data, all sorts of stuff. So in this case, we'll be sending latitude, longitude, altitude, speed, heading, and temperature, and actually the voltage supply data, all to a free cloud API called Dweet.io, which you might have seen in my previous tutorial on the LTE Shield. And today we will be investigating this example code I have on GitHub. So you can find all this on GitHub in the examples for the library. So the first thing you'll need to do is obviously download this library from my GitHub page. I'll post the link in the YouTube video description below. And this is basically, again, this is an updated version of the Adafruit Fauna library to work with my LTE Shield. And you'll find the example code under Code, Examples, and IoT Example. So this is the example that you want to pull up. I have it here already in Arduino IDE. You'll want to first obviously plug in your Arduino and have the Shield on top of it, and upload the code, and you should see the green power LED on the Shield turn on, which means everything is up and running. Make sure you have the antenna connected and SIM card inserted as well. Opening the COM port or the serial monitor, it will initialize, and right now my Shield has already been on, so the baud rate is already set to 4800, but if it wasn't already on, it would initialize at, it would be set at 115200 and it would find it instantly, but right now it's not, so it will find it in this next run here. So as you can see, it's kind of running through the process of getting a GPS location, temperature, battery, all that, and posting it to Dweet. So after running this code, and really you don't have to change much in this code, but after running it, should be able to just test if it posted by copying and pasting, sorry, not copying and pasting this whole thing, but just copying the IMEI number that it used to post to Dweet. And let's go here, and all you need to do is Dweet.io, get the latest Dweet for and the device ID, which is the IMEI number. When you press enter, should give you the latest values here. So in the content section of the JSON response. And as you can see, it has latitude, longitude, speed, heading, altitude, temperature, and battery, which is really actually just the voltage supply of the SIM7000 module. So anyway, right now I set it to post every 10 seconds instead of every 30 seconds, which is the default for the code. But let me run through the code real quick. So again, this is the IoT example here. And the first thing you might want to consider changing is, let's see, is this right here, this line right here. So sampling rate. So if you change this to 10, like I have right now, it'll sample around every 10 seconds. So it'll post, go to sleep if you make it go to sleep, and then it'll wait 30 seconds in this case, and then wake up, post again, etc. So change this to a lower value or higher value depending on what you want to do. And you can comment it out altogether if you only wanted to post once and then click the button. But for our example, that's no fun. We want to make a GPS tracker where we can drive around in a car with this thing and have it track our GPS location on something called freeboard.io. I'll post a link of the instructables in the video description. But basically, we're going to set up a dashboard in Freeboard and get all the data shown graphically on Freeboard. Everything kind of consolidated and graphically shown on the dashboard so we can view it in real time or after the fact. Another thing you might want to consider changing is this line here, although I would recommend you to keep it commented out. This line basically tells the Arduino if you want to turn on the shield or turn it off, leave it on or turn it off. So by default, it will just turn on, do all the initialization and setup, post to Dweet, and then it would stay on. So it's not going to turn off or anything. If you want it to turn off, so if you maybe have a low sampling rate and you're sampling maybe once every few minutes or something, and you want to save some battery life or something, then you might want to consider uncommenting this. But for my purposes, I'm just going to have it plugged into a car USB adapter, so that's not a problem for me. So I'm going to leave this commented out, and it's commented by default, so you shouldn't have to change that. So yeah, after you set all that, really everything should run. So based on that, it would just, in the current configuration, it just posts periodically and it never really turns off. So if it doesn't turn off, having the module remain on after it posts makes it a lot quicker. Because it doesn't have to reinitialize, establish serial communication, turn on GPS, turn on GPRS, and all that good stuff, and connect to the network. So it definitely saves you a lot of time, and you can sample a lot quicker. So as you can see here, it's rolled through quite a bit, and it's still going. So I guess now let's go to Freeboard. And first of all, I should mention that so Freeboard is a free. It's a free dashboard, IoT dashboard, where you can visualize all your data in one screen. So you can set up graphs, gauges, text, whatnot. So you can view all your data graphically. It's pretty cool because you can drag and rearrange all the items on your screen, and it's completely free, and it apparently has unlimited data. So if you look here, it says unlimited widgets, unlimited data, devices, unlimited dashboards. Haven't really looked into the upgraded versions here, but basically it's a pretty cool framework, and let's just get right into it. So here I've already created an account. It's pretty easy. You just when you click the red button in the home screen to start now, it'll basically bring you to a login page where you can create your account and all that. But anyway, I've already done that. So let's go ahead and start from scratch. As you can see, I already have it here, but let's call this GPS test and create new. So this is how you create a new project. So as you can see here, it's all empty. The first thing we need to do is add a data source. So the data source is just our LTE Shield and Arduino, which is actually the IoT device that's sending data to the cloud. So let's add this, and we're using Dweet.io. So let's click that. So the device is sending to Dweet. And the name can just be pretty much anything. Let's call this GPS test device. And the thing name in this case, because we're using Dweet.io, the thing name is the device ID that is being used, which is simply the IMEI number. So we scroll all the way to the top, or when it posts, you can see it here. But basically, we just copy and paste this, and that's the device ID that the example code uses by default. And we're not paying for any upgraded delete.io service, so we don't have to worry about the key. And let's click save. So now you can see it's up here, and it was last updated at on 10:55. Yep. So the next thing we have to do is add a pane. So there are multiple panes that can each contain widgets inside those panes. So let's just go ahead and do that. So as you can see, we have a pane here. If I add another one, adds another one. So on one of these, let's just click the plus button to add a widget. So you can see up here it says widget. Let's go ahead and add a Google map. Alright, so the next thing we have to do is add latitude and longitude. So in order to do that, we have to click data source and then click our GPS test device. And then it will show everything, all the variables that were posted along in the tweet. So whatever variables or values are being sent by our device will show up here. And for example, we're sending LAT as latitude in our tweet response. So if you go back here, we're sending it as latitude, LAT, and long, and speed, and head, and alt, temp, etc. So if we go back here, we need to select that. So we need to select this, and then select latitude. Excuse me. And then longitude, similarly, same thing. And draw path, basically you select this, it will connect the dots basically. I think it's a nice feature to visualize so you can see which one, the path it followed exactly without just showing a bunch of data points. So let's hit save. As you can see, it has a nice little map here. And yep, it's very accurate. And now let's see if it updates. So if we go back down here, it's still posting away. Oh, the thing is, it is very close, so it may not, it's posting the same value every time. So what we're going to do is, I'm just going to unplug my device for now, so it doesn't keep posting and burning data every 10 seconds. And what we're going to do is copy and paste this tweet URL, the post URL, and let's just tweak the number. So we're going to tweak the latitude and longitude numbers slightly just to get it to, just to fake it a little bit. So I'm going to post that in here, and let's just change it to like, let's just change a decimal place. So we don't want it to be off by like too much. And let's hit enter. All right, successful. So let's go back here, and voila, we see that it successfully drew another dot. It put another data line there, connecting the two data points. And yeah, there you have it. That's the Google Maps there, and then we can name it by clicking this little wrench symbol. We can name this GPS location. And there you have it. And let's add some gauges to show the temperature and stuff like that. So again, we add a widget, and then we select gauge. So it's asking for title. You don't have to put the title. I usually like to put it up here instead of down here. You'll see what I mean. So I'll put the title like here. And then, so let's add the widget gauge. And again, we have to add the data source value. So in this case, we're going to scroll down and temp, units, degrees C, minimum like -10, 45, something like that. Doesn't really matter for now. As you can see, the last reading was 26.13 degrees Celsius. Cool stuff. Let's just go ahead and add some more stuff. So we can add another pane. And as you can see, we can drag these things all over the place if we want to. So let's go ahead and add another gauge. Let's call this one, let's add speed. And this one's in kilometers per hour. Minimum, maximum 150, save. Alright, I'm not really moving anywhere, so it's going to be 0 mostly. Let's add a pointer, so to show the direction. So the Arduino is actually posting the direction heading, which is kind of cool. So let's go ahead and add a pointer. So it's basically like a compass, and the direction would be the heading from our DWI data, and then units would be degrees. So yeah, it's showing something down here, so it's definitely more than 180. It's like 225 or something, because north is 0 and then it increases like that. So that's cool. And last but not least, let's just add what's called a spark line. Spark line. So it's basically a graph that connects all the data points with a line. And here, let's just add altitude for fun. And as you can see, you can add multiple values here. So we can actually add, say, speed and altitude. So we can choose speed as well. And if you include a legend, you can you can include a legend, and you can also provide a label in the order that you place these values in here. So for example, altitude, speed. Save that. Has a little legend there. Obviously there's nothing there yet. So let's go ahead and run this thing again. Let's post something else again. So let's do like 320. Let's do like, this was like 250. So let's do like 120. Enter. All right, let's go back. And as you can see, yep, it did it here. So now let's plug in the Arduino again, and I'm going to restart the serial monitor. And it's scrolling through this thing again. Bear with me. So yeah, you can use this for pretty much anything. Data logging, low power IoT, data loggers, cool stuff like that. In this particular tutorial, I'll be using this as a GPS data logger, where I'll just basically have this in a car and drive around and see what happens. And yeah, it's pretty cool. So right now it's trying to get a fix on the location. It's a cold start. So right now this value here, this 5, is the number of satellites it's seeing. Right now I'm inside, so it might take a little longer, but it will definitely get a signal. Oh, there it is. Not too bad. And as you can see here, it posted, and if you could see the board physically, the lights are still on and everything, so it hasn't turned off. And it's posting again. So as you can see, it did post. See, you can see the 321.8 here. All right, post it again, and we can click refresh. If you zoom in here, it probably posted again, but it's just in the same place, so can't really see much of a difference there. But as far as temperature and things like that, yep, it's posting. So you just saw it change there. 23.5, 23.5. Yep, good stuff. Speed is 0, heading 0. Yep. So yeah, everything is working. So check out the instructables. I'll post a link in the video description below. Be sure to like, share, and subscribe, and I'll see you next time. Thanks.